Cool, so that was a whole whiteboard full of work.
Yeah.
Any place that you want to revisit or clarify?
So we had to figure out the energy first before we could find momentum.
Right.
And we'll have to do that anytime there's a moving object going into a stationary.
It depends on what information they give you originally. If they would have given us the velocity of the bullet, and then they said, what's the velocity of the block going to be after the collision, then we could have just started straight from here, because we would have already known this, and this, and this, and we could have just solved for that.
Okay.
But because they kind of turned the tables on us, and they gave us, well, they didn't give us either of these things, but because they didn't give us this velocity of the bullet, that made it really impossible to use this right out of the gates, because I mean, that's half of momentum is knowing the velocity. So if they don't give you velocity, it's really hard to do anything with momentum. So we had to kind of work backwards and find out our V2 by doing all the conservation of energy stuff, and then find V1 from there.
Okay.
So yeah, this is a tricky question.
Yeah, so there's a second part to this.
Cool.
That asks what fraction of the bullet's initial kinetic energy is dissipated in the collision between the bullet and the block.
Okay, so that's an easier question, so we're not going to have to go through quite as much work.
Okay.
So all we want to do there, we want to find out how much kinetic energy the bullet had before the collision and how much kinetic energy the bullet had after the collision.
Okay.
We already know how much kinetic energy the bullet had. Well, maybe we don't. So let's go ahead and find kinetic energy initial. That's just plugging into the kinetic energy equation, 1/2 mv squared. So we are going to say 1/2 times its mass, 0.001, times its velocity, which we just solved for, 943 squared. So that gives us 444.6, is that what you got? So 444.6 joules of kinetic energy initially. Its final kinetic energy, again, we'll just plug into that kinetic energy equation, 1/2 times its mass. And this one, so what exactly, how was the question worded? What fraction of the bullet's initial kinetic energy is dissipated in the collision between the bullet and the block? Yeah, I'm just wondering if we want to use the mass of just the bullet, or if we want to use the mass of the bullet and the block. Find kinetic energy final. I would imagine that you'd use just the mass of the bullet. So let's do that and see how that feels. So we use the same mass.
The same thing.
But now the velocity is much, much less. It came down to,
0.943.
yeah, 0.943.
So that's really small.
So did you get like 4.446 times 10 to the negative fourth? Yeah, so maybe, because if we used a 1 here, so if we use the combined mass of the bullet and the block, that'll make our, we'll still have like, it'd be like 4.446 times 10 to the -1, I think. Let me see really quick. 0.943 squared times 1 divided 2. Yeah, that might be the way to go. That is really tiny.
Yeah.
So if you use the 1 there, the velocity is still 0.943.
Yeah, either way, the velocity is going to be the 0.943. So yeah, if we use the combined mass of the block and the bullet, then we get 4.446 times 10 to the -1. And then it wants, so it's saying it wants the change in kinetic energy divided by the initial kinetic energy. So the change is always final minus initial. So if we take
This one.
so final, which is 4.446 times 10 to the -1 minus initial, which is
Is it minus or divided by?
well, change is
Oh,
minus
okay.
final minus initial and then divided by. Divided by 4.6. That's going to come out to be pretty much like -1.
Yeah.
That seems weird.
Where did the 444.6 come from?
This one?
Yeah.
That's the initial. So we took
Oh, that's right. That's what we got.
times the mass.
Oh man, I just didn't see that.
I did it the other, with the other one, the point, or 4.46 times 10 to the -4th, and it came out as the same thing.
Yeah, because either way, this is a really small number compared to this number.
Yeah.
So you're going to get pretty much -444.6 on top. That just seems weird for it to be negative, but it's final minus initial. What fraction of the bullet's initial kinetic energy is dissipated? So it's pretty much like 100%, but I don't know the whole fraction thing. I would just report whatever your calculator is telling you, but I would make it positive.
So it says 0.99999, so should I just say 1? Positive?
Yeah, does it say a certain number of sig figs or anything? Yeah, so accepted one.
Huh.
Yeah, that one's weird,
That's
because
weird.
usually you come out with something that's not that extreme. I guess it makes sense since it's a bullet, which is designed to, you know, like
Or something.
destroy stuff, pierce stuff.
And it
so.
was going really fast.
So yeah, it goes from having quite a bit of kinetic energy to having almost no kinetic energy. And that's because it's got such a small mass. So that's kind of weird, but